So welcome all. So we will actually continue with what we were doing. So remember in our last class, so this is usually what I typically do. You'll see along the way that I'll actually try to recall whatever we have done in the previous class so that you guys won't be lost and we can actually keep up where we were and such, okay? So basically, but the stuff that we have seen was, it wasn't that hard, obviously. As I said, that's going to be the most verbal part of this course. But what we were doing, remember, is that we were dealing with economic models, right? So we said that in economics, so we actually ask lots of questions, and we answer these questions with the help of what? So what were we using? What were we using? So we said that with the help of models, right? So, and models were what? So we call them economic models. So, but models were what? They were? So were they exactly the same replica of, the real world? No, right? So you said they were simplified versions of real world, right? So that's actually what we said. So these were simplified versions. And how were we simplifying? With the help of what? So that's what we said, right? So we should always, whenever we have a model, we should always keep in mind what assumptions lie behind that model, what assumptions we have, because usually the answer might be hidden there, okay? So we should be aware of that, and we should definitely give a lot of importance to assumptions. In some, sometimes people don't care about assumptions that much, but they are very important, right? So we discussed all about this. So we actually said that we do simplify, but we actually use assumptions, right? And then what else we said? Well, we said that, but we have to have a way of checking the validity of these models, right? So we have to have, you can say that, oh, this is my model, I really like this, so be it, right? But that's not the case. You said that we would like to understand what's going on in the world. We want to explain real world, right? So we actually said that we have to check the validity of these models. And then remember, we said that we can do it in two ways, right? So first we can do what? We can check either.
If the assumptions
right, so we can actually check the assumptions, whether the assumptions are correct or not, right? So we can use data, or we can just look at what's happening in the world, right? Or you guys, and then we said that, well, sometimes assumptions are unrealistic anyways. Let's say that, remember, assumptions, we said that from many times, a lot of times we're going to assume that you guys are identical. So if I take this assumption to real world, what's going to happen? It's going to fail immediately, right? So this is, but that model might explain some stuff, in the world, right? What's going on. So even though it's unrealistic, we know that, from a simple perspective, that model with even that unrealistic assumption might be able to explain some stuff that we see in the real world, right? So that's why what did we say? The second way, you can either test the assumptions or you can actually test, right, the implications. Your model would say something, and then you can actually test whether that, whatever your model implies is actually correct, right? It's what you see in the data, right? So basically, and then we said that, well, every economic model, depending on, the model, is going to have a different set of assumptions. But we said that we will have actually three common features, right, in economic models. Most of the time, these will be the common features of them, right? So the first one, what did we say? Do you remember? The first one that we said was, there is this thing called, right, ceteris paribus, right, or ceteris paribus. So we said, what did it mean? Remember?
Assuming
everything you assume, when you assume everything else being the same. So we said that, well, in our models, while we would like to incorporate everything, imagine that, and you'll see that these will be mathematical models, that I cannot account for every single variable, right? So what do? Mostly we do is actually we're going to focus on the assumptions, right? Focus on the essentials, okay? So whichever ones are actually of more use to us or to our question. And then we kind of, and we're going to leave some stuff out. But it doesn't mean that, we don't think that they're important, but we actually said that, well, whenever we say something, we assume all these other stuff are held being the same, okay? So basically, that's what we said. The first one was this ceteris paribus or ceteris paribus assumption, okay, that we would have in our economic models, right? And I think we were left at the second one, right? So the second one was what? It was like, you're going to see that in this course, remember in the first class we said, we're going to solve some sort of an optimization problem. Whenever we would like to understand the behavior of consumers, firms, or, like government, you'll see that they would be solving some sort of a minimization or maximization problem. It's sometimes constrained. Remember your problem, you said that, oh, hocam, I want to, sleep all the time, but I have to come to class too, because, I have a limited amount of time, right? So basically, sometimes it's going to be a constrained maximization problem or minimization problem. Sometimes it's going to be an unconstrained maximization or minimization problem, right? So we actually said that from time to time, you're going to see some sort of an optimization assumption. Okay, so this is what we said. You're going to see some sort of optimization assumptions, okay? So for instance, as we said before, that for instance, if you think of firms, right? They would be doing what? You guys told me. So they would be maximizing profit, right? So firms we know that they would be maximizing profit. Okay, so we're going to show profit like by pi most of the time. So consumers, you guys, will do what? So you would like to? You would like to be as happy as possible, right? So you can actually think of it like this. And we'll see later, we call that utility, okay? And then you would be you would like to maximize your utility, okay? So what else? Sometimes your friend was saying that firms might want to minimize their cost. And your friend was saying that, hocam, as a consumer, I might also want to minimize the money that I spent, right? So you're going to see later in this course, those are what we call dual problems. So we're going to solve, consumers would like to maximize utility, and then you're going to see they're going to minimize expenditure to actually reach that utility level. They would like to minimize. So these problems would be the dual of each other. They would kind of be identical to each other, okay? And you see that the optimal solutions will be the same. So, and this is going to be very similar for the firm as well, okay? And this is going to be, along the course, so these will be much more clear. And then remember we said that government, a benevolent government, right? So firms, they could either want to maximize profit or minimize cost, right? Consumers might want to minimize their expenditure, we'll see, to reach a particular utility level. And government, we said benevolent government, right? So they would like to maximize what?
Public welfare.
Yeah, right, public welfare, social welfare, whatever, right? So let's say social welfare, right? But of course, immediately, remember you said that, hocam, if you have a model where you assume that government is benevolent, it means that you have the assumption that the only goal of the government is to maximize social welfare, right? Is this realistic as an assumption? No, right? Unfortunately, no. So this is actually, so that's the case, right? That's what we said. Now, and remember, what did we say about your grandma? So we said that apparently all of you are solving some sort of an optimization problem. And then whenever we have an optimization problem, what are we going to do? what do we use?
Calculus.
Right, we're going to use calculus. Does your grandma know any calculus? No, maybe, I don't know. But, right, so, but she doesn't know any calculus. But remember, what did we say? Even though, or some of you, right, went 2 years ago, or a year ago, you guys didn't know calculus either, right? So remember, what did we say? So if we say that consumers are maximizing utility and they're solving this problem, do you actually solve that problem? Sometimes. Not, I don't, you know, and I decide on, you know, like how much to sleep, to prepare for a class, you know, like to do research. I don't do, you know, I don't write my functions or whatever. Remember what we said is that, remember the example of a pool player, right? So it's actually the guy, he is, so that the ball would go that way. If you want to calculate it, you have to know the laws of physics, right? You have to incorporate gravity, right? And all these stuff. So the cloth, the resistance of the cloth, the wind, whatever, right? So, but the guy is just hitting the ball, right? So it's not the case that we are literally solving these problems, but it turns out that these models are, I mean, our behavior can be explained best via these models, okay, using these models. So that's basically the case. Now, and optimization is good because it's going to help us use calculus, right? So that's why it's good to form, you know, like a problem, like an optimization problem, because we know how to handle it, right? So, so let's actually see an example here, so that hopefully it will be much, you know, easier to grasp. So remember, we gave the example of a model for like a profit maximizing firm, right? So let's say that, so let's write this, model of a profit maximizing firm, okay? Now, but this is, remember here, what was the assumption? We said that. The assumption was what? Right, the only goal of the firm was to maximize profits, right? So we said that, but we also questioned that, right? You guys told me that, oh, hocam, if I were the manager of that firm, I might want to, you know, go on expensive business dinners. I might want to fly business class, right? So, so that might not be, what was it called? Do you remember that problem? You're going to see later, not in this course, but in your principal agent problem, right? So that's actually what we said. Okay, so here we assume that the only goal of the firm is to maximize profits. So that's what we said. And for instance, suppose, so most of the time in these models, I will start my sentence, suppose this is the case. It means that, you know, it's kind of an assumption, okay? So suppose or assume a firm, okay, can sell all the output it wishes to sell at a price P. What does this mean? What does this mean? If I write this, suppose a firm can sell all the output it wishes to sell at a price P. Whatever that price is, we don't know, but what does this mean? Price at a price P, let's say per unit. So it means that whatever the firm would like to sell, it can sell every unit at a price P. What does this mean? No, not yet. So this is this has nothing to do with maximizing or, you know, minimizing. Yes.
I think it has a power on the price, determining of.
So, do you think like the firm has a power of the price? But so, like, can I say that? Do you think this how much the price is changing according to how much the firm is selling? Here, if I say this, no, right? So, like in this case, do you think price is a function of Q? Do you think this is the case here? No, right? So the more it sells, whatever, right? So it's the price is not changing. It says that for every unit, it can sell it at a price P, right? So this is, so in here, this is not the case. Price is just P. and it is not a function of Q, okay? So we call this, remember, the firm is a price taker, right? By selling more or less, the firm does not have a power, okay, on the price, okay? So this is basically, remember, this is an assumption. Is this true in real life? Not always, right? In some cases, it is correct. Remember, we said tomato producers, right? I don't know, like your grandfathers. So let's also incorporate your grandfather, right, into the story. So maybe, you know, like he's just doing some farming stuff, so he really enjoys it. And then from time to time, he sells his tomatoes, right? So he has to be a price taker, right? So it's very hard for him. But if it's a much larger firm, then we would say that price would be a function of Q, okay? So this is basically, this is an assumption. So you see, not only we assumed that the only goal of the firm is maximizing profits, we also assume that the firm is a price taker, okay, here. Then, and suppose, let's say, again, so suppose cost of production, okay, cost of production depends on amounts produced, okay? So basically Q. So it means that, so here we also say that cost of production depends only on Q, okay? Because sometimes it might depend on other stuff as well, right? So again, this is kind of a simplifying assumption that cost of production depends on amount produced, okay? Now, fine, this is actually the case because, for instance, what could it depend? Other stuff, my cost of production.
The markets or raw materials? Energy.
So it's, of course, right? So these are, but you'll see that these would all be incorporated in the cost function, later we'll see. But for instance, in some cases, suppose, you know, there's this huge competition for the workers that we hire. Let's say we're in Silicon Valley or whatever. So it will be depending on what the other guys are doing, right? If they're producing a lot, they might be demanding lots of labor. They might be increasing the prices, right? The wages that you have to pay those workers. So it would not only depend on how much I produce, it might depend on how much the other guy is producing, because there will be a competition to get those, right? Let's say software engineers, okay? So that there would be, so here this is again an assumption. So you see at the end of this course, you might tell that, hocam, you know, like these models are too simple, but that's okay. So we'll learn these basic ones, and then you guys, but always keep in mind that, but there is this assumption and this is not realistic. Okay, in my further studies, right, in the future, I want to drop this and I want to see, you know, how things work out, you know, when I don't have that, okay? But for this simple case, we assume this is the case, okay? Now, basically, so then if I want to write down profits, okay, I can actually write down my profit. Profit was what? So for people, right, so it's what we call total revenue minus, right, total cost. So what is total revenue here? How much money this firm is going to earn? It is P times Q, right? If P was a function of Q, if P were a function of Q, it would have been something like this, PQ times Q, right? And then we said that apparently this total cost, let's call it C, suppose we have apparently it's a function of Q, I don't know. But you guys told me that, oh, hocam, this is not PQ. You said that because the firm is a price taker, this is P times Q minus CQ, okay? Now, so let me write it here. So now, you told me that the goal of the firm is to maximize profit. So what would this firm do? This firm would like to maximize its profits, right? So let's try to do, if we would like to maximize a function, whether it's a profit function, okay, or so let me be actually proper. So apparently this profit function, right, is going to be a function of Q, obviously. This is P times Q, CQ. Now you said that, hocam, this firm would like to maximize profits. If you want to maximize a function, what do? You take, right, so, all right, so let's do this. So we're actually looking for the profit maximizing Q, right? The profit maximizing quantity. So how much this firm should sell, how much this firm should produce, okay, in order to maximize profits. Fine, so we actually have this. So is it okay if I put this? Or I should put a D, not a dal, but a D. Because it's only a variable of Q, right? So I can actually, I don't have to put dal, I can actually put D, okay? So this is basically, you take, okay, what is the derivative? So you take the derivative, right, with respect to Q, this is what? P minus, so whatever this functional form, we don't know, right? But it's C prime Q, right? And then we set it equal to 0. Now you see, this is our condition. What is this? So if you want to write this down, so this is P equals to C prime Q, okay? So what is this? Does this look familiar to you for your friends who have taken introductory econ? What is this? What is C prime? What is the derivative of total cost? What was this? Right, so it's marginal cost, right? So this is what price equals to marginal cost. Remember that was in the perfectly competitive, whenever the firm is a price taker, that's what you have seen. The firm is going to set, you know, like price equals to marginal cost and would be producing at that quantity, right? But is this enough to check? So is this enough to check that this is basically a maximum? So at this, you know, like at this Q, which satisfies this condition, we're going to call it Q star, let's say, okay? So is it enough to check only this? Right, so remember, you take the derivative, you set it equal to 0. It could either be maximum or minimum, right? So how do you guarantee that it's the maximum? Right, so we have to look at another condition, right? So what was this? What was it? Do you remember? Should be, but for a maximum, it should be what? So all of you are saying right stuff. Some of your friends are saying that, oh, hocam, it should it be concave or should it be convex? If you want to, you know, like have a maximum, do you have a maximum in this kind of a function? What kind of a function this is? It is a convex, right? So, and this one is concave, right? So this has a maximum, right? So basically we have to figure that out, that it should be, because we would like to maximize, it should be a concave, right? So we should make sure that this condition is also satisfied, and this condition is that for a function to be concave, this should be less than 0, right? Good. So this is basically, if I take the derivative again with respect to Q, what is it? It is, so this does not depend on Q, right? So it will just go away. So there's the minus, and it will be the second derivative, right? So, and you guys told me that, hocam, this should be less than or equal to, so this should be less than 0, okay? So basically, and then we actually say, this would mean that this is greater than 0, okay? So let's actually say where Q star is the profit maximizing output level. Okay? So you see, now we figured that out. So we said that apparently in this model, so this C function should be, now this C function is what? Its second derivative is positive. Should it be concave or convex? Convex, right? So apparently this function should be, but remember you said that, hocam, for a maximum to exist, it should be concave. So this profit function should be concave, definitely, okay? So this part is linear, so it's, you know, it doesn't matter, it's both concave and convex, okay? This part is linear, so this part, it says that should be convex, and if you have a minus in front of it, it will be concave, right? So altogether, this function is, this profit function is concave. So there is a maximum. The maximum exists, okay? And what does this mean? Now we see it as a condition, but again, if you need to explain it to your grandma. So what does that mean? It means,
each time rate of cost increases.
right? So it says that what does this say? Marginal cost is,
Convex.
it is increasing or decreasing. Remember, marginal cost was this guy, right? So we called it marginal cost. So this is the derivative of this guy, and it says that the derivative, the first derivative of that is positive, right? What does that mean? Marginal cost is increasing or decreasing? It's increasing, right? So it says that the profit maximizing output should be where marginal cost is increasing, right? And remember, that's exactly what we were saying. Remember, in your previous econ courses, probably you have seen a marginal cost curve like this, and we never set the profit maximizing, right, quantity level here on this part. But we always said, right, so this was price equals to, for instance, marginal cost. So let's actually have something like this. We'll see all of these, but just to remind you, right, suppose price was this, firm was a price taker. So it could be equal to marginal cost here and here. Remember one of that, and we were taking this guy as the profit maximizing output level, right? It should be where the marginal cost is increasing, okay? So this was basically because this is where actually you maximize the loss. Okay, so that's what we were doing. I don't know whether you remember, but don't worry, we'll see. Okay, so this is basically the case. So now we figured out some stuff. So it turns out that marginal cost. So if you need to tell it, your grandma might not know marginal cost, but at least it's better than this, right? So you can say that the profit maximizing output level should be where the marginal cost is increasing. Okay, so let's actually, marginal cost must be increasing. Okay? Actually, let's put it strictly increasing because it's, like a strict inequality. Increasing at profit maximizing output level, Q star, okay? Good. So this is basically the case. Now, so let's try to figure out what's going on here, right? So we had all these stuff. So let's try to figure this out. So for instance, let's see what kind of assumptions we have. So we actually talked about this, but what kind of assumptions we have? For instance, let's say in terms of ceteris paribus assumption or ceteris paribus assumptions, okay? So what do we assume? So we assume that some stuff are, like changing, yes. But in terms of ceteris paribus assumption, what do we say? What do we, there are some stuff that we didn't even mention, right, in this model. So what are they? But which would definitely affect, right, stuff. So some of you were saying, right, hocam, energy costs, right? So they're somehow embedded in this cost function, right? So, but basically, so you can actually say that, so let's put this, for instance, input prices, right? The prices for wages, prices for capital, right, physical capital, which we would call rent, okay? The prices of raw materials that you guys were saying, or energy prices, whatever input prices. Here in this model, right, we did not even mention them, so we kind of assume that they're not changing, right? So we're holding them the same, okay? So these are input prices. What else? What do you think is actually being held constant, for instance, in this case? Do you think the firm is, here we allow that the firm's technology is changing, right? So like they're now doing wonders.
Technology is constant.
Right, it is constant. We said this is the cost function, but we didn't say, like maybe that cost function is changing, right? They figured out something really cool, and now the costs are really low. So the technology is also, you see implicitly, it's also being held constant, okay? Technology is the same, right? So it's being held constant, right? So you can come up with many stuff, right? So Like, or you can actually say that the cost structure, this functional form C stays the same. It doesn't change, right? So that's actually what we say. So you can actually call it cost structure, basically. Okay, so you just assume all these guys stay the same, okay? So what kind of an optimization assumption that we have here? So let's see, you hold, as I said, that you hold these guys constant, they don't change. What kind of an optimization assumption do we have here? What do firms do? They maximize profit, right? But is this a constrained maximization or unconstrained maximization? Firms maximize profit. Is this a constrained maximization? Did I write any sort of constraint when I'm maximizing that function? Or, so let's actually be proper and put max, and we're maximizing with respect to Q, right? This one. So is this a constraint or an unconstrained optimization? Unconstrained, right? There is no constraint. I haven't written anything, okay? So this is actually an unconstrained optimization problem, which is easy, right? Which is much easier. If we have a constrained maximization problem, what do we use? Do you remember in calculus which techniques you used? Lagrange, right? So we're going to do that. So we're going to use Lagrangians very intensively, okay, in this course. But here, you don't need that, okay? Now, let's actually, okay, so this is the case. So so you guys tell me, what is an exogenous variable here? And what is an endogenous variable here? Okay, all the stuff that we have seen. What is an exogenous variable? What is an endogenous variable? What do firms, take as given? What is an input to the model? Price, right? So they don't actually decide on this price is the output price, right? And what is an endogenous variable? What do they decide, right? Within the model, we solve for it. We're actually looking for that variable. What is it? Quantity, right? So how much they're going to produce. So this is going to be actually the quantity. So this is going to be determined within the model. This you take as given, right? So the model, in the model, this is, we don't know how prices are determined, right here. We just take that as given, okay? So this is basically the case. So you see that now we know the assumptions. And remember, we talked about the models would sometimes imply something. And sometimes it might not be that immediate. You might need to look for it a little bit. So let's try to figure out something that this model, this very simple model, implies, okay? So check this out. So let's see. Suppose there is a little bit of a change of price. So what do you think the firm should do? Suppose price increases a little bit. Do you think the firm should increase the quantity that they produce or decrease the quantity that they produce? Do we know? I don't know. I have to, so let's see. Okay, so let's solve for it. So you see, from now on, the question that you would have in your mind, most of the time you won't have this. Oh, I'm going to have this model, The things that will come first to your mind won't be models. They will be questions, okay? It would be a question like, if price is, if it increases a little bit, right? Then what's going to happen to the optimal quantity? How much should I be actually supplying, right? Or selling? So this is going to be the question that you have. And then you will let me use this model and let me try to see what this model says, okay? So let's actually see that. And what I will do is going to be this. So you guys tell me, what was this? Okay, so let's actually put Q star here. If Q star is the profit maximize, it's the optimal output level, right? Profit maximizing output level. What was this? It has to satisfy which condition? This should be equal to what? Yeah, don't be afraid, you're saying the right thing. 0, right? So, okay, so let's have this. So this is 0. Okay, so let me, of course, this is because taking derivatives, right, it means that it's actually not that much of a big change, but it's kind of a, you know, like smaller change in that neighborhood, right? So let me do this. So let me actually dq, okay? So let's have this. So I'm going to take the derivative of both sides with respect to q. What would be this? 0, right? Okay, so apparently this guy is equal to 0. This I know, okay? So I write this. C prime q star dq. So let me write down my question, okay? How will the firm, okay? How will the firm react to a change in price? Of course, a small change, okay? We don't know. We want to figure out. Let's see whether this model, bless you, whether this model is helpful, okay? So what is this? So we said that, okay, so this should be equal to 0. That's what we said, right? So let's try to take. So let me take this derivative, right, with respect to, okay, I wrote this, but am I actually answering this question here? I made a mistake. So I want to know when price changes, how firm will change its optimal quantity, right? So is this, if I look at this, it's going to answer my question. No, why? What should I do? I should take the derivative with respect to p, right? So this is wrong. So this is, I don't know, you just take the derivative of the first order condition, again with respect to 2. This is what we have done before, right? To check for the concavity. So this is actually, this should be p, right? So because this is what I want to know. When p changes, how this optimal q star is going to react, right? How it would change. So this is basically, so I write here p, okay? Now, so then I take this derivative. So I take this derivative with respect to p. What is this? It is 1, right? Minus, now, so what about this c prime q star? Q star is it q star itself, or it's a function of what?
It's a function of price.
It's a function of p, right? So you should be careful that, you know, you should always keep in mind that, remember, this q star is actually defined via this here, this relation, right? At the profit maximizing quantity. So let's put this p c prime q star. Suppose you know c prime, what kind of a function that is. You're going to write q star would be a function of p, right? So when you take this derivative with respect to p, you have to take that into account, okay? Later on in this course, we're going to see something like an envelope theorem, and we'll come to that, okay? So then we don't have to solve it like this. There would be an easier way to do this, but for the time being, I just want you to get the idea, okay, of the intuition. So you know that, oh, hocam, this is a function of p. So when I take the derivative, I have to take that into account, right? So what would I do? I actually say that so you can actually put it like this, c prime q star. So you take this one's derivative with respect to q star, you know, like whatever the variable. First you take the derivative, okay? And then it's the chain rule, do you remember? And then you actually take the derivative of this q star with respect to p. If q star was not a function of p, then that derivative would have been 0, right? But here it's not. So, so let's actually say that, don't forget, okay, q star is actually a function of p, okay? So that's why I have to be careful. So I have to take, so this is how I would take the derivative of this guy with respect to p, because q star is a function of p, right? So then, and then we said that this is equal to 0. What mathematical object here answers my question? So which derivative that you see here is actually the answer to the question that I write? How will the firm react to a change in price? right? So second, which one? Say it. dq star, right? This is a mathematical way of, like saying my question, right? When P changes, how does firm react, right? How does the optimal quantity react, okay? So this is something that I'm interested in. And this is going to answer my question, right? I didn't know, but now I learned. So this is dq star dp, right? So I want to look at that. If it's positive, then you would say that, oh, hocam, when price increases, apparently they increase the quantity that they supply, right? They sell. Or when price, increases, they decrease the quantity that they supply or sell, right? So this is here. So you see, this is not hard. So from here, we can actually get this, right? So this is basically, and what is this? Before I move on, what's that? So what is actually, it's, I'm taking C prime's derivative with respect to Q again. Don't worry about the Q star there, but what is it? It's the second derivative, right? So that we have learned. So you can actually, instead of this, you can put this guy, okay? So this is what, so we have actually, so if you want to write this, right? dq star, so if you, so this is, okay, so let's solve this. 1 is equal to C prime Q star, right? dq star dp. And I want to solve dq star dp is equal to 1 over C double prime Q star. Do I know what C double prime Q star is? I don't know. It's the general function, right? We called it C. But can I know what this derivative is? Can I know whether it's positive or negative? Yes, right? That's why we did this. That's why it was important for other reasons as well. But you see how important your, like whatever you have done, your assumptions and everything are. What did we say? We said that this guy, if Q star is the optimal quantity, then this second derivative should be positive, right? So then if I say it's positive here, then if this is positive, this whole guy is positive. Check this out. What did we find? Apparently when price increases, this price taker firm is going to react to it by increasing its quantity, right? So you see in the simple model, even that, we have something that we can relate to real world, right? So then what would you do? Suppose your model tells you this, and then you want to check the validity of your model. What would you do? You go and check, right? So you go ahead and check the data and see whenever price increases, do firms really increase their quantity, right? Firms of this type though, maybe tomato producers, right? The price taker ones. So you see that it's not an assumption. You see, it is actually an implication of your model. And you can call this, so this is a testable implication. Okay? And you can actually go ahead and check that out. Okay? So I think this is a nice example that you can see that, oh, this is the model, and this is the testable implication. What is an assumption? What is actually what my model implies? Okay? And remember, I wrote down, so I'll say this and then it will be, I will be done. Remember, I said that there were 3 things, right? So the first one you said, hocam, ceteris paribus. The second one is the optimization, which are common to, like all economic models. And the third one, have you heard anything called normative versus positive analysis? Do you remember? So let's call this normative versus positive, you can call it analysis. Have you heard anything like this? So I'll tell you. So this is actually positive analysis, and this is what is going to be most of the time in this course and mostly in economics. Positive analysis is going to tell you what is. So what is the case? It's going to provide you the facts, okay? Suppose you think of the minimum wage regulation. So do you think it's good or bad? It might depend on your values, right? Your judgments, like what kind of a person you are. It depends. But as a scientist, you have to provide what is. So what we do in economics, we actually say that, oh, you know, whenever you have the minimum wage regulation, you know what minimum wage is, right? Asgari ücret. So whenever you have the minimum wage regulation, who are the losers? Who are the winners? How much do they lose? How much do they gain, right? So you just provide these facts, and then you leave it to government officials or, you know, other people to decide. Then in order to decide, and then it would mean that whether you value those losers more than the winners, right? Or you value the winners more than the losers, right? So this is basically, so positive analysis is going to just provide the facts, okay? So they will be objective facts that, you know, like that, who are the losers, who are the winners, how much do they lose? But in the normative analysis, it tells you what should be the case. And then you say that I value workers more than, you know, like the owners of the firm, right? Firm owners. Then for me, minimum wage should be there, okay? Then this is actually a normative statement that you make. You say this should be the case. But as scientists, we have to provide the facts, okay? So this is going to be, again, lots of time. It will be a common feature of all these economic models, okay? And then next class, we'll start with consumer theory.